In section 3.3, we are going to be still taking derivatives of functions, but we're going to be taking derivatives of functions that come in the form of a product or a quotient. So we're going to learn the product rule and the quotient rule. To start out, let's go ahead and review a few key concepts. First of all, if I'm taking the derivative of a sum or a difference, the derivative of the sum is just the sum of the derivatives, meaning I can take the derivative of each component. And this is a nice rule that we've already been using in section 3.2. Our next rule is going to deal with products. In this case, the derivative of a product, and by a product I mean a function times a function, and the functions in this case will be named f of x and g of x, does not equal the derivative of the individual factors. So the derivative of a product is not the product of the derivatives, and this is very important to remember. And you never want to make this mistake. This is like one of those big mistakes on a test. If you take the derivative of a product as a product of the derivatives, it doesn't matter what else you do, you'll lose full credit. Now this same rule also works for quotients. In this case, the derivative of the quotient, and here's my quotient, the function f of x divided by g of x, does not equal the quotient of the derivatives. And so again, this is another rule that we want to keep in mind. So the two things we want to come away with here are basically these last 2 points. The derivative of a product is not equal to the product of the derivatives. The derivative of a quotient is not the quotient of the derivatives. I need special rules to deal with both of these. The first one that we're going to look at deals with products. So let's go ahead and look at the product rule. The product rule as stated in your book is pretty straightforward. This particular theorem, first of all, both your functions have to be differentiable. Then the product is differentiable as well. And what this says is the derivative of the product. So this means fg prime of x. The derivative of the product is equal to the first function, which is f of x in this case, times the derivative of the second function, plus the second function times the derivative of the first function. Now there's a lot of different ways to remember this, but that's how I typically remember it. First times the derivative of the second plus the second times the derivative of the first. The easiest way to start working with these is to go ahead and look at an example. In this example, keep in mind that we're looking for a product. So let's take the derivative with respect to x of x cubed times 2x plus 1. Now, quick point, I don't have to use a product rule on this. I do have two functions being multiplied together, but I could distribute through the x cubed and use my good old-fashioned power rules from the last section. So keep in mind, product rule is not required here, but we are going to use it. So for my product rule, I'm going to have my first function times the derivative of my second function plus the second function times the derivative of my first function. So let's go ahead and go through that one more time. The derivative of the product is equal to the first function times the derivative of the second plus the second function times the derivative of the first. Now we actually have not taken the derivative yet. I've just written out the work here. So drag along the x cubed. The derivative of 2x plus 1 is 2. Drag along the 2x plus 1. The derivative of x cubed is 3x squared. So that would be my derivative. It's not simplified, of course, but that would be my derivative. Now if we were to go through and simplify this, I'd have 2x cubed plus 6x cubed plus 3x squared. Combining like terms, 8x cubed plus 3x squared would be our solution. So therefore, f prime of x, or we could call it y prime as well, is equal to x cubed plus 3x squared. That's my derivative. Because that's my derivative, that's the slope of the tangent line at anywhere along the graph of this original function. Now, what's another way we could have done the same problem? Remember, I noted at the beginning of this, I could have just taken the x cubed and distributed it through to each term of the binomial. So this would have been the derivative of 2x to the fourth plus x cubed. And of course the derivative there is pretty straightforward to take. I just use the good old power rule. I bring the 4 down, decrease the exponent by 1. Bring the 3 down, decrease the exponent by 1. And I have 8x cubed plus 3x squared. So these match. These are both my derivatives. And clearly this second method is easier, but some problems you cannot choose whether to use the power rule, or sorry, the product rule or not. You have to use the product rule in order to take the derivative. We just looked at this example because it kind of showed how that was a requirement. Let's go ahead and look at another example as well. In this example, we do have a product. I have a first function and a second function. I think the first thing that we should do is probably rewrite this. I'm looking for the derivative with respect to x of. We want to take 1 over x and rewrite it as x to the negative 1, because then I can apply the power rule when it comes time to take that derivative. So if I wanted to, I could FOIL this out and use my old power rules, but this is complicated enough that we probably want to leave it as is and go ahead and use the product rule. So product rule says to take the first function times the derivative of the second function. And again, I'm not actually taking these derivatives right now, I'm just writing out my work. So again, first times the derivative of the second plus the second function times the derivative of the first. Okay, so there's my setup, and let's go ahead and take those derivatives now. Again, dragging along this first component, there's my first function. Now I want to take the derivative of the second function. The derivative of the second function, I'll drag the 2 along, I'll bring the 4/5 down, and then I'll decrease it by 1. Well, 4/5 minus 5/5 is a negative 1/5. And of course the derivative of 1 in this particular case is 0, so I'm done there. Plus, dragging along 2x to the 4/5 plus 1. The derivative of the second, I'll bring the negative 1 down, decrease the exponent by 1. The derivative of 2x is 2. So there's my product rule, and of course we need to simplify a lot from here, but here's a start on it. So when we're going through the steps of simplification here, and again there's more than one approach that we can take, but for the most part we can rewrite x to the negative 1 as 1 over x. We can simplify, flip this into our denominator. Okay, it's same thing over here, flip the x to the negative 2 into the denominator. We can find a common denominator here and in this second factor over here, and then find the common denominator overall, and here would be our common denominator. And then once we find that common denominator, go ahead and multiply through by the common denominator and combine like terms, and this is our derivative. And I really think that practicing your algebra and simplifying completely is a fantastic idea because it strengthens your algebra skills, which makes your calculus skills stronger too.